So this first presentation is about service mesh. So obviously, if you're here for this DevOps and cloud track, you are running probably distributed systems. And I would like to know here who is using, for example, AWS for his production workload. Anybody? Yeah. GCE maybe? No? And your own on-premises VMs? Okay. And there you probably run some different orchestrators, so maybe Docker, Swarm, okay, Marathon Mesos, known, and Kubernetes. Oh yes, one Marathon Mesos there. Okay, and Cube a bit more. Okay, so all you will understand that service mesh is going to bring you value, because I'm pretty sure that you are not using them in production yet. Is there anybody using a service mesh in production here? Oh, one there. It's an introduction, so maybe it's not going to help for you. Let's go. So, the clicker is working or not? No. Yeah, it is. So, I'll start by a definition, and I picked the definition of William Morgan. William Morgan is basically the guy who wrote with his company Buoyant the very first service mesh. It was called Linkerd. It's called Linkerd. So service mesh is a software infrastructure layer for controlling and monitoring internal service-to-service traffic in microservices application. So I would say that it's pretty accurate, except that the internal part. This definition is somehow 1.5 years old, which is old for the timeline of a service mesh. And now the service mesh tend to extend a bit more to the edge of your cluster. It's no more internal, but today for the presentation I keep it internal. So let's have a look in deep to this definition. First, infrastructure. What does that mean? That means that should be transparent for your application. All the added value will be without any change for your microservice or distributed applications. Controlling, when you say controlling, it means controlling the traffic by injecting dedicated configuration into the system. We'll see example later on. And finally, monitoring. It's 2 points here in monitoring. It's traffic monitoring, volumes, latency, for example, but also tracing. Where is my transaction flying in the system in between my services? And then the context somehow, it's for service to service internally in your cluster, in your distributed system. And normally for microservices, but I would say it applies for distributed systems. So if you're running a set of services on top of VMs that are not yet microservices, still it can apply. So which service mesh should you use, or at least try, if you have not? The choice is quite limited today. There are only two. I would say Linkerd and Istio. Linkerd was there first. Okay, they have users in production. They have ton of success story. And there's Istio, which is the brand new one, let's say, which is surfing the Kubernetes wave. And it's backed by a lot of big players like IBM, Red Hat, Google. So up to you to make your choice. There are some differences in terms of architecture, of course. Maybe I'll come back to that at the end or in the question section. So why would you need a service mesh? If you have containerized already your application, you're running Marathon, you're running Kubernetes, you're in the cloud, why the hell would you need a service mesh? Well, in fact, if you're using these orchestrators already, you are happy probably with the way of deploying your application. You can launch instances, scale your application, you have some basic bricks for service discovery, but it's not enough. The service mesh will help and brings more value to your cluster in terms of traffic management, observability, and security. But before detailing the three of them, I would like to explain what really composes a service mesh, what makes a service mesh. So your system, the one that you are running today, is the ping part, probably. So you have VMs, bottom right, running services, distributed most probably in containers. And you have a control plane, let's say the Kubernetes master, if you're using Kubernetes, that configure and manage this cluster. Okay? And next to that, we're going to add two other pieces that will make the service mesh. It's also made of a control plane, like the kube master, but here it would be, for example, Istio master processes, that will host a configuration for the routing, with, for example. And next to this control plane, we have the data plane. This data plane that is configured by the control plane is made of a set of proxies. These proxies are distributed in your system automatically. I said it earlier, it's transparent for your application. And they won't be distributed the same way depending if you're using Istio or Linkerd. Linkerd, it will be on a node-based, and with Istio, it will be on a, let's say, it's a sidecar container pattern, so next to all your applicative container. What is important to understand is that the traffic here is flying only on the bottom line through proxy and through services. The traffic never hits the control plane, just like the traffic never hits the Kubernetes master or Mesos master or whatever. Okay? So two blocks, control plane for configuration and data plane. But this data plane is also reporting, and this will to the control plane. This will help for the observability part. So let's dig into the traffic management part. You may have seen this picture on the web, the Death Star architecture. Just imagine that every single point is a service in your distributed system, and each service calling another one, and so on and so on, and you end up with this big star. So let's make it a bit simpler. Let's have only 3 services, A, B, and C. A calling B, calling C, calling B, and then C. And let's imagine that we have just round robin between all instances. So this is typically something that you would have if you let the service discovery of Kubernetes act in your system. But if you're running on GCE or Amazon and you want to be HA, you are probably running on top of several availability zones. Who's in this case? Here and there. Okay. So if you're in this case and you're not using a service mesh, you have transactions that are flying from one availability zone to another. And this transaction not only may be slower than the one that stay in the same zone, but also they are more expensive. They are going through different mechanisms in terms of routing, and you are built for that. Okay? And the service mesh, especially the one that comes with Istio, is availability zone aware. That means that once your client have reached your cluster, every communication that happens inside your cluster will remain, when it's possible, inside the same availability zone. I say when it's possible because let's imagine that C1 and C2 disappear from the picture, then the B2 may be allowed to call the C3, crossing the zones. Okay? Also, with this kind of architecture, you may have some instances in your system that you want to qualify differently for different purposes. For example, canary testing, A/B testing, or you want to dedicate some instances for some users, sharding your system this way. So here I represent this with colors, and you want your traffic basically to stay this way. Everything that is reserved for a client will be in red, for example, and the rest in black. Still, it's the same deployment that you're using. A instances are all the same and so on, but you want to segregate your system in terms of traffic. So here, a service mesh can help also. Here is the kind of configuration that you would have to inject in your system to achieve this. Here, for the B, so you see host B means everyone that is targeting the service B. I want to define a subset that I call red subset, and all the instances that are labeled color red, or could be canary, okay, or something like that, or A/B testing, blah, blah, then we'll have to receive any traffic from other instances that are also labeled red. Okay, so depending on the system that you are using, Kubernetes, VMs, or I don't know, I'm not sure it's working with Swarm, you will have to pick up the identity of your workload from labels usually. Other example, you want to send only 10% of the traffic to some dedicated instance. Here you apply some weight to the destination. So the configuration is quite simple and understandable. When it comes to traffic management, there's also the failure management part. You probably have heard about the circuit breaker pattern. So when you talk target multiple instances, one of them may be failing, and you want to stop sending traffic to this instance, at least for a while. Okay? Now that we have injected proxy inside our distributed system, the proxy can play that role and have the circuit breaker running inside him. So you don't have to code the circuit breaker in your application. It can be done, it's done in the proxy that is injected by the service mesh. Another feature for failure management, the retry. So it's not applicable for all services, okay? But let's imagine that we have just a read service. Every time your proxy is calling an instance that is returning an error, so that means that the proxy needs to understand the protocol. So for example, it understands HTTP. So if you receive a 500 server error, he may decide, if you have configured so, to go to another instance and try to get a valid reply. So if we look at the graph, at the top, we have the success rate for the A service. So before the retry apply, we see that we have a 50-50 in terms of success and error. And when the retry feature is activated, we have only success on A. Still, on the bottom part, you have the same representation but for B. And here you see that you still have a mix of error and failure, but also with an increase of traffic. Of course, because we are generating more traffic applying this pattern. Observability. If everyone needs to monitor the volume, the success rate, the latency, and so on, you're not going to ask every application to do so. So you want the platform to do that for you. Same for traceability. You need to pass token between applications, and you don't want the application to deal with this token. So the service mesh will help you there. Thanks again to these proxies that are injected in the system that represent tons of control points in your system that we can leverage. So these control points are even more efficient if the traffic that is flying in your system is understood by the proxy. Means that there is a compliancy at protocol level. So today the protocol that are understood by Istio are at least HTTP, gRPC, and some for DBs. And this list is not exhaustive, and it's growing every day. And you can have then the proxy reporting the metrics to the control plane, and you can then have aggregated view. Here is an example of a dashboard that you would get. So at the top, global figures about what's happening in your system, and then you can drill down services per services to understand what's happening. What you can draw also, and this is how they draw probably the Death Star graph, is the relation between all services. And you can also annotate these graphs with KPIs that you have grabbed from your system. Then open tracing is a new standard for tracing, and it's compatible with the service mesh. This allows you to drill down on where is the time spent in your system when a transaction enters the system. So here you can have such a graph without, again, touching your application. Finally, security. 2 blocks here. First, between proxies, you can activate encryption. It's called MTLS. And for example, if my A and B and C server were just HTTP1 simple servers, and I have some requirement for traffic encryption, by injecting the service mesh, automatically I will have encryption. And this also comes with automatic revocation and replacement of certificates. Okay, you don't have to deal with certificates, it's done automatically for you. There are new features that have been introduced recently in Istio. It's the roles-based access control. So first, who is allowed to configure the service mesh, on at which level, which action, and so on. But also service to service. I can say that I don't want my A service to call my C service. I can define this, and any attempt to connect will be rejected by the proxies that have received this configuration. So, in the past, very long time ago, we had it's a bit of history now. Monolithic applications, so we didn't have any interest in a service mesh that was not existing, by the way. The only thing that we would have cared about is load balancing, maybe between our servers. Then came the big web giant, and they started to have problems, the ones that are solved by the service mesh. But at that time, All these guys on their side, they were all doing almost the same thing. Building libraries that they use and they link against in the application to deal with this problem. So Google, Netflix, Twitter, Facebook have their library. In AMADEUS, we created also a piece of middleware to deal with this. And today, we come with another pattern, okay, which is the service mesh one. So just imagine that the green boxes here are your services, microservices running in your cluster, and that the blue one represents the proxy, the sidecar container proxy that have been injected automatically in the system, and that allow connection between pieces of services that are distributed in your application. Okay. So if you have only one thing to remember about service mesh and what it does for you and what it is, think about it as a distributed set of proxy that you can configure through a dedicated control plane, and that will help you to deal with traffic management, observability, and security. And now it's time for a question.
Okay, time for questions. In French, I mean, if you don't feel comfortable with English questions, you can ask them in French. Hein, vous pouvez les poser en français. Si.
Je vais la poser en français. Je sais que sur Amazon, il y a une démarche qui est en train d'être faite pour faire justement de la gestion d'infrastructures et d'applications en tant que service également, et ça ressemble beaucoup à ça. Est-ce que c'est de ça dont il s'agit, qu'ils sont en train d'intégrer sur Amazon, ou bien c'est quelque chose de plus générique, ce que vous nous avez présenté?
Alors, pour sûr, c'est générique dans le sens où c'est applicable sur toutes les plateformes que j'ai pu citer, et je dirais généralement au-dessus d'un système distribué. Après, je ne vais pas pouvoir répondre à l'autre partie de ta question parce que je ne sais pas à quoi tu fais référence. Donc, je ne peux pas te répondre.
C'est que moi, je l'ai vu récemment et je ne sais pas non plus encore exactement de quoi il s'agit. Donc,
mais oui, c'est tout à fait générique dans le sens où, si je reviens sur le slide d'architecture, quand le control plane du service mesh contacte le control plane de ton système, aujourd'hui, ça peut se connecter à Kubernetes, ça peut parler en n'importe quoi. En fait, il y a des API qui sont définis. Il suffit que ton système implémente cette API et tu vas pouvoir bénéficier du service mesh. Globalement, les appels qui sont faits entre le control plane bleu et le rose, c'est récupérer toutes les informations qui sont de l'ordre de la service discovery, en fait.
D'accord. Très bien. Merci.
Alors moi j'ai une question par rapport à la sécurité. Donc du coup tu disais que c'était possible de déployer des connexions sécurisées, TLS, à travers le service mesh. Et la question que je me posais, c'est est-ce que la connexion est aussi sécurisée entre le proxy et ce qui est exposé par ton application?
Par le container, non. Ouais. Non. Alors si on prend le cas de Kubernetes, tu auras un pod avec ton container applicatif HTTP1 qui va essayer de parler à un service distant. Ce qui se passe réellement, c'est qu'au niveau des IP tables de ton pod, tu as une règle qui va le forcer à passer par le proxy. Et cette connexion-là, qui est une connexion qui passe tous les layers TCP, hein, mais qui reste dans le localhost du pod, n'est pas encryptée.
Mais ça reste sur la machine, la même.
Ah oui, ça reste sur la même machine, parce que
physique. Okay.
Dans le cadre de, enfin, avec Istio, ton sidecar container est instancié à côté de ton container applicatif, donc ça sort pas de la boîte.
Et donc du coup, ça marche avec Istio, mais avec.
Alors avec Linkerd, c'est ça ta question avec, avec Linkerd, en fait, le pattern, c'est que le sidecar proxy, c'est pas vraiment un sidecar, mais tu en as un par nœud. Donc tous les containers en fait qui sont sur la machine vont avoir leur trafic rerouté vers le proxy de ce même nœud. Donc encore une fois, tu ne sors pas du nœud.
Donc ouais, la connexion est tout en fait avec localhost.
Exact.
Ok, merci.
De rien.
Y a-t-il des impacts sur les performances de l'application?
Alors,
il faut répéter la question.
Ouais, est-ce qu'il y a des impacts sur la performance? Alors, évidemment, on rajoute un bloc. Donc, on va rajouter un petit peu de latence. L'évaluation que j'ai fait dans mon entreprise, on passait de toute façon, parce qu'on avait toutes ces problématiques à résoudre depuis une dizaine d'années, on passait par un service bus d'entreprise. Et en fait, globalement, on va ni gagner ni y perdre en termes de performance. Aujourd'hui, par contre, si vous loadez deux applications A et B et que vous les faites communiquer directement et qu'après vous rajoutez un service mesh, oui, vous allez introduire un petit peu de latence supplémentaire. C'est inévitable. Ça, c'est de l'ordre de... ce que j'ai pu mesurer sur GCE, c'est de l'ordre de 4 millisecondes pour traverser deux proxys. Parce que normalement, en direct, on a un seul hop de A vers B. Et là, on va avoir un hop local de A vers le proxy, du proxy vers le proxy et du proxy vers B. Donc on a fait plus de hop. Alors, ils travaillent énormément sur ça dans la communauté. Et notamment, si vous êtes intéressé sur ces problématiques-là, je vous encourage à aller voir ce que fait Cilium, qui, qui trafique un petit peu la connexion entre l'application et le sidecar proxy pour utiliser eBPF et éviter de traverser toute la couche TCP. Et on a un gain de performance de l'ordre de x5. Plus de questions, désolé.